Okay, we see another problem in hexagonal prism. So you can see that we have to construct an hexagonal prism dimension 25. So hexagon of dimension 25, axis length 50 mm. So rests on HP on one of its edges of the base. So we have to construct an hexagon with respect to the base edge on the right hand side. Draw the projections of the prism when the axis is here. So when the axis is inclined to HP at 45 and VP 30. So when the axis is given means it is an beta angle problem. Okay, so first we're going to construct XY line. Okay, so this is VP, HP and Y. So we have to construct an hexagon here with respect to edge. Dimension 25. Okay. So it is 60. Okay. So now can take a dimension of 25 and we have to cut the arc. So this 25. Okay. Again can keep the protector here. Mark for again 60 degree. Okay. So here also mark for 60 degree. So here also we have to cut 25, already we have cut it. Okay, so we have to join this. Okay. So we can write the notations now. E, B, C, D, E, F. Okay, bottom face notation B1, C1, D1, E1, F1. To find out the center of the axis, we will draw thin lines. Okay, thin lines, thin diagonal lines we will be drawing. Okay. So exactly at the center we have O and O1. Okay, now projecting this. So axis length is 50. So here so for the top face notations we write A dash, B dash, C dash, this is F dash, E dash and D dash not visible. Okay, similarly A1 dash visible, B1 dash visible, C1 dash visible, but F1 dash, E1 dash, D1 dash not visible, O1 dash, O dash also not visible. So now we will go for the base edge inclinations. That is 90 minus inclination to HPT is 45. So 45, that is we get 45 here. Okay, so here we have C1 dash and D1 dash. So we will keep the protector here, mark for 45 degree. Okay. First arc, second arc. Okay, so we can write this is our E1 dash, F1 dash, this is B1 dash and E1 dash, this is O1 dash. So these vertical lines are exactly perpendicular to this, so we can mark at taking a reference of this, we will be marking at 90 degree. Okay. Now drawing a line of length 50 mm. So now we can join this. Okay, so I can write A dash, dash, this is B dash and A dash, this is C dash and D dash, and this is O dash. So by extending this, okay, here we can show an axis. So if you measure the exact angle, you will get it here. It is exactly 45. Okay, 45 degrees. So now by projecting downward, so by projecting the lines from both sides, first we'll write the notations. Okay, so here, so this is A, this is B, this is C, this is D, this is E, this is F, and at this point we have left this point, it is O. Similarly for the this is for the bottom face, right? E1, B1, C1, D1, E1, F1 and O1. Similarly for the top face also we can write. Okay, so this is A, B, C, D, E, F. Okay, this point is O. Okay, we know how to construct the second position top view. That is, first we have to construct an outer boundary line here. Okay, first we have to construct outer boundary line. Yes. It is connecting here. Here and this outer boundary line it is done. Now visible space, as it is looking from the top we are able to see this face and this. Okay, so the top hexagonal face it is visible, so we write the hexagon here. Okay, and this rectangular face also visible from the top view, F1 and A1 visible from the top view, but this base of the hexagon not visible from the top view, so part of it is written with the dashed line. Okay, and then this rectangular face C dash, G dash and C1 dash, this rectangular face also not visible, so we can show part of it here. Okay, and we can show an axis here, so this is an axis line. Okay, so now this is an angle of inclination to VP, it is 30 degree, but so this problem it is an beta angle. Okay, so here we have, this is having 50 mm, right? So this is your first axis length, and this length, okay, from O1 to O, this is your second axis length. Okay, considering these two axis length 1 and 2, we can, so 1 and 2 we can done the third position. So here in we will take here the axis line here, so this is mark reference point, then marking reference point will be marking at this 30 degree angle line. Okay, so axis line it is drawn, it is 30 degree. So what is the procedure is, first we have to take this 50 mm axis length. Okay, you can extend this. First I will take a reference point of O and I will be measuring this axis length first, that is 50 mm, measuring 50 mm. And cut the arc. So this point it is O2. So after drawing this point you have to draw an locus line here. Okay, then after that you have to cut the arc from this, from O to O1. And the arc, so this is O1. So now you join this an axis and then extend and find out the beta angle. So here for this we are getting an beta angle of around 50 degree. Okay, now we have to transfer the diagram. Okay, this diagram here. So here you can see that we have 2 points O and O1. Using these 2 points we have to construct the rest of the diagram. So here we have this O point, so I can construct this from this O and O1. You see that O and O1, so I'll be constructing the rest of the diagram. So from this O point, O to F and O to A, these 2 points are same. We'll be cutting 2 arcs. Okay, then I'm cutting from this O1 point to F, O to F and O1 to F. Okay, so this point it is F and this is A. Similarly you can cut is O to E and O to B. You can see that these two lengths were same. Okay, so from this point only you can cut it. We have 2 points. Okay, F to E and A to B. See, this is B. Again we can cut this O to D and O to C. Okay, now reverse it. F to D and B to C. This point it is D and this point it is C. Similarly we have to construct this one from O to D and O to C1, O1 to D1 and O1 to C1. Okay, and from here again reverse it is O1 to D1 and O1 to C1. So this point it is D1, this it is C1. Now O1 to E1 okay. Now from D to E1 this is E1 and B1. And again from O1 to F1 and O1 to E1. Okay, now from here E1 to F1, okay, then B1 to E1. So this is F1 and this is A1. Now so we have to join this. Okay. Then from these two hexagons first we complete these two hexagons, then we'll join vertical edges. Okay, so now we have to finish the final position. To construct the final position, here we have to consider two nearest point. Okay, so before that first we construct this final notation, this one and this one, top face of this front view, top face of this. Okay, first horizontal line projections. Okay, now we will do one by one. So till here, so this point it is A dash. Now here we have, so this point is B dash, And similarly we have this point, and this point it is C dash. Okay, C dash, and D point it is this is D dash, D dash, and we have this point is F dash, and exactly the center we have this point, this is O dash. Similarly for the bottom face also we do it. Okay, so this point it is E1 dash, B1 dash, C1 dash, D1 dash. This point is E1 dash, and this point it is F1 dash, and we have this point it is O1 dash. Okay, so here you can see that the nearest edges are E and D, so I will write here nearest 2 points to x5. Okay, so that is E and D. So E point you can see that is near connected to E to D and E to F. Okay, and then E to E1. Okay, E to E1. Similarly we have D. D is connected with E, D is connected with C. Okay, and D is connected with D1. So these are the dashed lines. Okay, first we are going to complete the dashed lines here. Okay, E to D, and that is E dash to D dash. Okay, and then E to F, you can see that. Okay, E to F. And then E to E1, E to E1. Okay, now we have D to is done, D to C. Okay, now D to D1. Okay, so these are the dashed lines done. Now we will complete the base of the hexagon. Okay, so this base also will complete it. Okay. Okay, now from A dash to A1 dash, and then from B1 dash to B1 dash. Okay, now finally we have axis. Okay, so this is how we complete the problem.